Welcome to Summarize Science, where we break down the latest breakthroughs in technology. Today, we are looking at a revolutionary paper titled CubePart, which introduces an open vocabulary, part-controllable 3D generator. Generating 3D objects with AI is already possible, but most systems create a single, solid mesh that is very hard to animate. Think about a car in a video game. You need the wheels to spin and the doors to open, but most AI just gives you one big solid block. The researchers behind CubePart realized that 3D assets are rarely static and need to respond to physics or scripted events. To solve this, they created a system where a user can provide a list of names for the specific parts they want an object to have. This is what they call an input schema, which acts as a structural blueprint for the AI to follow during generation. The process works in two distinct stages to ensure the final result looks coherent and works correctly. In the first stage, the AI generates a full, holistic shape based on the user's global text description. In the second stage, it takes that shape and carefully decomposes it into the individual part meshes requested by the user. To make this work, the team had to build a massive new dataset because existing 3D part libraries were too small. They used a specialized data engine that leveraged other AI models to cluster and name over 2 million parts. This resulted in a dataset 11 times larger than previous efforts, giving the AI a deep understanding of how objects are built. They even used a clever technique called set-of-mark rendering to help the AI identify parts from different angles. When comparing this to older methods, the difference in quality and control is quite dramatic. Previous systems often produced noisy boundaries or simply failed to follow the user's specific part list. CubePart consistently creates separate, structurally complete meshes that fit together perfectly. This ensures that every requested part is present and correctly emphasized in the final 3D model. Because this system is open vocabulary, users can get really creative with their prompts. You could ask for a dwarven steam-powered drilling machine or a fantasy cottage perched on giant mechanical legs. By varying the schema, a user can even control how detailed the breakdown is, from a simple 2-part model to a complex 8-part assembly. This level of control allows the AI to handle ambiguous components like fenders, mirrors, and stands with high accuracy. The most exciting part is seeing these models in action inside a real game engine. Because the parts are separate meshes, they can immediately be hooked up to animation scripts. The researchers demonstrated this by making robot frogs that spin, drones that hover, and wizards that swing their staffs. It effectively bridges the gap between AI-generated art and functional assets for developers. While there are still some challenges, like parts occasionally overlapping at the contact points, the results are stunning. The gallery of generated assets shows everything from futuristic weapons to medieval plate armor and biological mechs. Each of these was created simply by typing a description and a list of parts. It represents a future where the barrier to creating complex 3D worlds is lower than ever before. To recap, CubePart is a major leap because it treats 3D objects as assemblies of parts rather than solid blobs. This is made possible by a massive labeled dataset and a 2-stage process that ensures both global shape and part-level detail. In the future, this could allow anyone to build entire interactive universes just by describing them. Thanks for watching Summarize Science, and we will see you in the next breakthrough.